My name's Mo. I'm not Noam, who was supposed to be here, but was unable to make it. I promise I will still try and make it as entertaining, even though I'm not as funny as he is. So today we're all here at HumanX. This is my first HumanX, so I wasn't sure what type of audience this was going to be. As I forgot my intro slide, just a quick bit about me. I've been a security engineer for the last 10-ish years, where I decided to go make a pivot since all these really cool things were happening in the AI space. I joined Alice about a year ago, where we really focus on like full cycle AI security and everything that means. Now, for everyone that means something a little bit different. Everybody's adopting AI at different paces. It's a very confusing time right now, but it's very exciting as well, right? We just found out that there's a model that nobody has access to that is breaking things we didn't even know could break. So I think this is like a really timely topic. What does AI red teaming look like outside of a lab? If you are a serious red teamer practitioner, could you like raise your hand right now? Great, you're going to have the worst time here today. This is not going to be as in-depth as you'd like it to be, and I'm really sorry about that, but you are more than welcome to find me, and we can go and talk about things that are crazy. So just a show of hands, does everybody work at a company? Okay, cool, everybody works at a company. I mean, you could be a consultant or something, right? So at your company, is there some sort of security review process? Yeah, raise your hand, please. I know, just admit it makes your company look good. Okay, great. And now, do you guys have any sort of like red teaming at your company? Yeah, amazing. Keep your hands up, raise them really high. Okay, great. That's like not even a quarter of the room. Amazing. So just remember that your company does red teaming. That's a really important thing. If this was a little bit like more intimate, I'd ask you, what does red teaming mean to you? But that's not this type of conference. So I will tell you what it has meant to me in the past. I've worked at a ton of different organizations, from media organizations. I've done consulting for finance. I've worked in gaming. And everyone was always more worried about people coming into production and making things really complicated for customers or making things really difficult to deal with. And we always worried about locking doors. And locking doors is a really important thing, right? I mean, I sometimes forget to lock my door, and my cat gets out, and he just goes on a meowing rampage at my neighbors. But I don't think doors are actually like the most important thing, right? We have windows, but like, does anybody ever think about the integrity of a wall? No, because walls are supposed to be like pretty good. I'm also a big video gamer, so it's okay if you don't get this reference, but yeah, that door is actually locked, but the wall fell down. Turns out someone had placed an explosive on the wall, and it blew up the wall and them. But yeah, clearly there's an issue here. Not all doors are meant to stop people from blowing up your walls and getting what they want to. So to kind of like explain some of this, I've made this talk. I wanted it to be really like relatable. So I'm going to bring up a bunch of examples that you've probably seen in the news to kind of help you understand some of it. All of this is from the last 12 months, so you should at least be able to think about it or know about it or laugh about it a little bit. But yeah, we had this happen, right? An update got pushed to X, and out of nowhere we had crazy anti-Semitism just blowing up on the platform. We had users getting attacked and named by, again, their names, and people just getting doxxed, right, by Grok. And now it's like, you go into an X thread and you see Grok everywhere. Or it's like, hey, Grok, like, what's this weird image? And you get a response in thread. Imagine seeing the same thing and seeing anti-Semitic content. Or anything else. We also saw the same thing happen when it was going and same image models were being used to undress people, right? So these models are kind of crazy, right? And within 24 hours of that incident happening, again, it's causation. I can't really say that this is exactly why that CEO resigned, but within 24 hours, that CEO resigned. McDonald's had the same thing happen where, well, not the exact same thing happen. I wasn't being fed anti-Semitic content while ordering a burger, but it happened with their AI recruitment system, right? Except it wasn't just like a chatbot that was going rogue. It turned out that the default credentials for the system of that recruitment system was 1, 2, 3, 4, 5, 6, right? And you can't really just say, oh, well, if these credentials are leaked, 64 million users are impacted. No, the researchers were only able to access a couple of accounts, but there was also not enough logging to understand the full scope of the attack, or at least the vulnerability. So you have to assume the worst in this case. And that was a third-party vulnerability. And this next one is kind of like one of the ones that really hurts. We see this happen, unfortunately, not just once and not just twice. And I think it's the most kind of stark one because it's a real reminder that there's some human weight to AI. So when this happened and character AI was, again, kind of being held accountable for this, this was the first time like the Kentucky AG had to go and say, well, someone needs to be held accountable for what AI is saying and what is actually being output to the users. So these systems have real human consequences aside from the security consequences. And over the last couple of years, I think we've all seen it, but security and safety have kind of become combined in some weird way where safety testing and security testing are very hard to understand. The craziest part of all of this, and I'm looking at y'all who said your companies do red teaming, is that all these companies did red teaming too. So red teaming, it's not equal everywhere. It means something different for everyone, and it does mean that the quality of testing and how deep the testing goes is different. So today we're just going to talk a little bit about like exactly what maybe enterprise red teaming has looked like. What are some things that we can do to kind of move away from like the stigma that is enterprise red teaming, and kind of some things and frameworks that exist today that can help you understand or take red teaming and bring something back. I don't really think we need to reinvent the wheel when it comes to security. While there are some things that we do need to change and do differently, most of the frameworks and things that we need to be able to build a solid security program already exist. We just need to start applying them. And hopefully by the end of this, you'll be able to say, oh, well, I think we can already do this. Let's just start taking small steps towards that. So over, again, the last 10 years, I've built a couple of security programs, and they've typically looked like this from a high level. And when we started to adapt some of these programs for AI, they changed just a little bit, right? So you take your automated scanning, and it can be your SAS tools, your DAS tools, and whatever you're now using to understand what is happening in AI. You take your benchmark evaluations. So this can be an AI evaluation. This can also just be how your product performs on a normal basis, right? This used to be more of like a QA type of thing, but we've now had to adapt it for AI as well. You have your human red teaming exercise, which is, again, it's based on those cases that you understand and that you know about based on your user stories, but it's not always catching these edge cases. Your guardrail configurations, again, something newer for AI, but again, this is something that is just blocking certain categories of attacks or expected outputs and kind of what you want, and you hope everything else gets captured too. You have your penetration testing, which is different than red teaming in many ways, but again, it's one of those areas that's a little bit nuanced. But for the sake of this talk, we can think about this more as like your infrastructure around your products. And then your vendor safety attestation. So shout out to all my homies in GRC. This is for you. So we've taken all of these enterprise processes and like said, hey, well, this is how we're going to test our AI in our company. So what does this actually mean at the end of the day, and what are you doing when you've completed all of these activities? Well, one, you'll now understand how your model is actually looking in a production environment, how it should look like by your clients and your customers. Two, all the scenarios that your team made and said, hey, these are the things we definitely don't want our AI to do. In your enterprise testing model, you've now said, oh my gosh, this is great. Like, we have nailed what we need to nail, and then everything else is just outlier and is totally just like, we didn't even know it could happen. And then 3, with users that don't exist, which is kind of one of my favorites, sometimes you just use synthetic data, or you are using test cases and bots, and you're running, you're basically just running tests with data that you hope is going to happen in the real world. And this is usually based on either what past data that you have on users, or data that you're anticipating to have. But in 6 months after you've been in production and you've noticed different changes in how your users are actually using the product, all of this stuff changes, including the types of models that you have, how your model's actually now responding, how you need to do alignment, and even your infrastructure, right? New vulnerabilities pop up every day. We can't forget about traditional security. The problem with all of this is that attackers move really fast, and they tend to break things really fast too. So all of these metrics and stats are really cool, but like, what do they actually mean? All of these are relating back to models that have been broken in the last year. When we look at the 64% jailbreak rate, this is from Cisco, and they tested a couple of different models, and they noticed that most models can be jailbroken quite easily. When you look at the 93% up there, this is more focused on the open source models. And we actually, shout out to our org, we released a really cool research report on how you can go and take the weights out off of these models and take off all the guardrails and make them do whatever you want. 90% success rate of adaptive attacks. So when attackers start to get more creative with the ways that they want to break your models, they can pretty much get what they want at the end of the day. And this was done by OpenAI, Anthropic, and DeepMind, and this was very recent. So I think it was within the last 8 months-ish. And again, all of these organizations just got together and said, oh, AI is really bad. Here's like a secret model we've not released, and we're going to use it to find all the issues. And this last one's actually kind of fun. 35% of security incidents caused by simple prompts. Now, what constitutes a security incident in this case? Likely some loss of CIA, right? Confidentiality, integrity, availability. And for I don't know how to pronounce it, Adversera, when they went and did this study, they actually got a lot of organizations that were losing over $100,000 based on some of these simple prompt attacks, right? These small prompts that can cause much bigger outsized impacts. And it doesn't stop there, because now agents have also changed everything. Like, everything keeps coming up and coming up and coming up, right? There was the Microsoft Copilot thing that happened where it was just, basically RAG poisoning. And a couple steps later, it was just spitting out all of this type of information, data exfiltration, very fun. And the SalesLoft one is, again, for my GRC friends, this is a prime example of why you really need to pay attention to third-party, fourth-party risk. I've highlighted it there, but I think the next slide is way cooler because it's got an explosion. 700 companies were technically compromised within 10 days because of a third-party dependency failure, right? Or at least a third party. So it's really a fun environment that we're in. And you can't pre-test your way out of it in all cases with what we've got for at least enterprise safety today. We've covered most of this in the last couple of slides, but just one more time, I was told to make slides look pretty that people could take pictures of, so this is your camera slide. And then I was also told to make more single slides with really big headlines, so here's another one. Yeah, that's a shield. I thought it was a strawberry when I first saw it, and they were like, no, that's a shield. Okay. But safety is not an event. It is an event, but sure, it's a system too, right? You're not looking for safety at a single point in time. It needs to be a continuous process. You need to be measuring it, and you need to understand it, how it is in context with everything that's happening in your environment as it evolves as well. So let's start to take a look at some of the frameworks. And I'm not going to bore you with going into every single one, and I'm not going to go in depth. I'm just going to pick, honestly, the things that I thought were most fun and important from them, and attacks that I thought were cool. So the first one that I always bring up, everybody knows it, OWASP. Or if you don't know OWASP, I'm sorry, I just outed you. But OWASP LLM top 10. Really, it's just a list of very, very good stuff that you should really pay attention to in terms of AI security. The ones that I have here are the ones that I've seen a lot of attacks happen in in these last 12 months. Prompt injection, sensitive information disclosure, improper output, and excessive agency. I think these are also the most relevant just based on the time that we're in too. And recently there was also the release of the agentic top 10, which takes some of these risks and recontextualizes them specifically for agents. So you do have things like rogue agents again, you do have excessive agency, but now it would look like tool use, etc. And the next one you have is NIST, right? And NIST gives us these 4 really big, easy to remember areas to focus in: govern, map, measure, and manage. It's kind of like the dodgeball thing. Whenever I see that, I just think dodgeball, if you can dodge a wrench or whatever. But that NIST framework is another one that if you actually go and read through it, it's not very helpful, to be honest. But if you look at it from like a larger standpoint, it's vague enough where you can go and pick areas in your organization that are like, hey, we need to like really focus on mapping. How can we actually get mapping done? And mapping is just understanding where your agents or at least understanding your solutions in context of each other and where they are in your environment. Same thing for measuring. It's like if you don't have measuring already in your organization, this NIST framework gives you a really good way to get measuring started. It's not going to tell you exactly what to do, but it'll give you the steps that you need to take in order to get measuring in a good place. And think like an attacker. Now, the one person who raised their hand and said that they were the red teamer, you probably recognize this as well. I've literally just adopted this from OSCP. And if you've ever taken the OSCP, or you've looked at the OSCP, or you've thought about taking the OSCP, this is basically what it's based on. And when I started getting into hacking and doing all this red team stuff, the big thing that I was always told was to think like the robber, not the cop, or think adversarially, and don't do the thing that your mom would say don't do, or do the thing your mom said. You get it. My mom would be very disappointed. So I kind of broke these down and I took them because I think actually the OSCP and specifically that way of thinking about attacks and thinking about attacking systems is really relevant even with AI. So when we think about doing like our first threat model, or we think about reviewing an application or a use case in AI, recon is kind of what you start out with, right? You need to understand. You're usually meeting with teams. You want to figure out what their use case is. You want to figure out the tech stack. You want to figure out the underlying model. You want to figure out what they've already done, where this is shown up in other places. Do they even need it, right? You want to understand everything about it. And you want to start putting that into a framework that everybody can understand, whether that's architecture diagrams or mapping them to Jira stories or wherever it exists in your organization, however it exists, you need to start attributing some of these findings or at least some of these thoughts somewhere. I know that in my past it's basically been a hell of Google Docs and program management plans and finding where the TPM sits and say, hey, like we want to see like all these features and like what you've been doing here, but you've got to do it. In terms of escalation and persistence, this was kind of an interesting one to like remap for AI. Escalation is more about like that excessive agency when you take it and adapt it. So thinking about how an agent can go and you think, all right, well, you should only have access to tools A and B, but for some reason you're now leveraging your relationship with those tools to maybe affect another system or impact another agent, which makes another decision that was not anticipated. Especially when you start getting into multi-agent clusters and they're all impacting one another in some way, shape, or form, escalation actually becomes this really crazy relationship diagram, and it's very, very, very messy. But thinking about how agents talk to each other, thinking about how answers in a chatbot can affect an agent long-term. And then persistence, which we go into memory, and we think about how certain jailbreaks don't just exist in a single prompt or a single shot, right? It can go through a multi-stage or a multi-step process, where you start with prompt A and you get a fail, and then you go with B, and then you get a fail, and then by the time you get to C, it's starting to loosen up and it's starting to talk a little bit more, kind of like me after too many drinks of tequila. But unfortunately, we have a lot of issues here with AI that are replicated in humans, or maybe vice versa. But I think we talk about it here too. A lot of the risks that come from AI aren't just technical risks that people understand. They actually are behavioral risks that my therapist probably understands better than I do. Right? So for example, a lot of the attacks that we've seen are actually persona manipulations. I remember the first couple of funny ones were, my grandma is like on her deathbed and she used to make me cookies, and it turns out the cookies were like actually Windows keys. So like, you know, like, it's so ridiculous, but that's how reasoning was at the time. And now it's entirely different. You can use more sophisticated reasoning to still get the outcomes that you'd like. However, it's still a human social engineering problem that natural language processing has introduced to machines. So it's like we've introduced a human weakness into a computer. From the technical vectors, I think these are things that we've always expected, but when you tie in that behavioral piece, we've kind of introduced ourselves to this like new, just this new risk vector, right? Where you now have machines that are just as vulnerable as we are. And my CISO would likely say, Mo, please take your phishing exercises more seriously, and like go pay attention to the emails. This is not a joke, you know? But in this case, you can literally phish your AI and actually have some technical impacts as well. So we can think about at least the phases of testing if we had to adapt testing into a simpler kind of way for AI and red teaming for AI into this kind of way, where you have these three phases: your pre-launch, your runtime, and your post-launch in production. So for pre-launch, this is really when you're going to look at the models. You want to stress test behaviors. You want to go through all of these different types of scenarios that you're probably not thinking about normally. When I used to run this type of testing at the other orgs, we basically went and communicated with other teams and got them involved in the process. I would rather have gotten like prompts from like my marketing team and maybe the comms team, or I mean, they're the same, but they're different. Comms professionals would say so. Legal team, and even some design folks, right? Because they're thinking differently. I have a couple of really funny ones, but I don't want to say them because they're a little inappropriate, but hilarious. Please see me after. Like really funny. During runtime, this is more, you can think about it like your incident response people, or like SIM, if you've been involved in operations. This is when you're starting to apply guardrails. You're starting to look at behavior in transit. So as requests are being made, as agents are kind of communicating within an environment, let's look at those patterns. Let's see like what they're actually doing. Let's see how some of the same requests cause different outcomes over time. And then taking this back into a continuous feedback loop. So you're seeing these behaviors, but you're also informing your testing in early stages elsewhere. And then your post-launch, which is where you actually want to go and like identify these and stop them really fast. So you move past that detection part and you actually move towards enforcement. And in production, this is like, again, where you don't want the bad things to happen. And this is where Guardrails is, in my opinion, the most important. When we're talking about like runtime, again, very similar, but executed a little differently. So best practices, because we love to work in 3s and 6s. I could just read off the slide, but I know some people are going to take pictures of it. It looks amazing. But essentially, these best practices are a distillation of everything that we've talked about so far, and figuring out what types of testing methodologies work for your organization. And these are some kind of good ways to establish those testing habits as well. So figuring out your own robust testing methodology is important. Again, we have all these frameworks that are very vague that I would say are open by intent, right? Even the EU AI Act is very much large compliance standard with lots of regulation behind it, but it doesn't specifically say, you need to do X, Y, and Z using this technology. You need to use, it's not prescriptive, right? It's more, if you do these sets of activities, you can be compliant. So you need to figure out what those activities look like in your organization. Considering bad actors and benign actors, all of this, it's a product kind of thing. It's a user story. It's understanding exactly what these people attacking your application look like, or what these bots attacking your application look like, and then recontextualizing it for yourself. I'm not going to go and walk through all of these. These are just two examples that I wanted to pull, but again, if you have any questions, feel free to ask. And the big one is security teams can't do this alone. This brings up a really big conversation about like, what does risk look like in an organization and who owns risk. I'm never, ever, ever going to try and take that and say like who owns it. I think everybody will just get into like a Smash Brothers brawl over it. But AI risk, again, is behavioral, and it is operational, and it is technical. So many teams have to at least consult with each other on risks that are associated with their AI systems. And I know this doesn't sound like it has a lot to do with red teaming, but when you think about it, red teaming is testing a system, and the system for your organization are all these teams combined, right? When you look at a release process in an organization, you need to understand what the people behind it are doing, how they're doing things, what they're releasing, why they're doing it the way they're doing it. All of these things can lead to vulnerabilities in one place or another, especially when it comes to AI and agents. I've had many instances where I've worked with a marketing team in past organizations where they would go and release a product that we had no idea about, and it would cause lots of issues for the org down the road. And if we had known about it previously, we would have been able to red team it early, we would have been able to test it, we would have been able to validate some of the things. So everybody has a role here. And like we said, there's no single playbook. Everyone fails somewhere differently, and that means the priorities for your organization are different too. You might be the type of organization that would rather build versus buy, and in that case, you may want to be more stringent on how you're testing internally. You may be a smaller organization that loves to use tools externally. Well, then your third-party process needs to be a little bit stronger. So the run book doesn't work for everybody. You need to consider exactly what type of organization you are and how you're employing AI and exactly where these solutions are coming from. One of the things I did want to talk about, though, are benchmarks. Not necessarily, oh, benchmarks are great, but we need to talk about like why benchmarks aren't like an answer to red teaming. Again, your benchmarks aren't going to be dictating exactly, oh yeah, this model is good for this use case. Well, actually, that's exactly what it does, but it's not going to be, well, is this model going to perform well under stress over time? They answer different types of questions than a red team exercise would. So when you're doing all this red teaming, I would say consider these 4 things as like your kind of guiding star. Your exploitability, adversarial persistence, bypass, and deployment risk. And I promise this is the last time I've numbered something on a slide. I just know that it's easy to remember things when you attribute numbers to them. Also, if you ever have to put it in a list, it's easy. So the first one, separate evaluation from adversarial testing, is to address the benchmarking thing, right? Benchmarks measure performance. Red teaming measures misuse. It measures how a system breaks. They're not the same. You have to treat them differently. Continuous testing, not periodic audits. Don't run a weekly scan. Like, let's monitor the environment as it changes. Agents change daily. They change almost per interaction. So I'm not saying look at every single interaction your agent has, but maybe look at the outcomes and results that your agents are providing over time and consider them when you start to look at those systems. Assign ownership beyond security. This is handled in a lot of organizations in different ways. So if you have got an AI council at your org, if you've got some sort of board, then that's a really good way to kind of think about ownership and who can assume risk for AI. Design for drift before it happens. While this is difficult because you don't know when drift is going to happen, that's exactly why you need to prepare for it. Drift is probably one of the most dangerous things, mainly because it can cause a slew of different types of issues. And measure learning velocity and not just your incident count. And what I mean by this is things will break for sure, but look at how much they're breaking and look at how frequently they're breaking. And see if that, if it continues to break and you continue to see peaks and spikes, it might be a one-time thing. However, if you're seeing it continue over a long period of time, you may have a more foundational issue. So, last but not least, the guiding questions. Who's trying to break your system? How fast do you learn when it breaks? And does your security team know your business logic well enough to attack it? These kind of things are exactly how I would probably perform a test nowadays. Obviously, maybe a bit more technical, but that's it. And then the very catchy last slide. The lab tests your model, the real world tests your organization. Cool. So, the marketing team would be mad if I didn't talk about some of the cool research we were doing. We also have researchers here who would be mad if I didn't talk about the things they were doing. So we recently did hacked some AI toys, which were really cool. You can go scan the QR code and look at that. You can find a lot of the content that was here in Demystifying AI red teaming. But again, the serious red teamer walked out because he was falling asleep. So if you are interested, he would scan that. Otherwise, he can come by our booth. And then I also have a podcast that we host with Alice called Curiouser and Curiouser. This week's episode is Your LLM Has No Idea What It's Doing. I didn't know that the episode was named that, but that's pretty funny. So it's good to know. And then we have an engineering blog where we talk more about the cool things that we hack. So I wasn't supposed to leave time for questions, but I do have time for questions. So if you have any questions, please. Yeah.
This is really interesting. Thank you. My question is differentiating between when the call is coming from inside of the house, meaning what is the mental model for? You used to think of attacks coming from malicious outside partners, but now you can have agents that are going off the rails.
Yeah, so it's kind of a difficult thing to think about, right? But we've been doing insider threat for a really long time as an industry. It depends on really how.
Not a person.
Right.
But like an agent going.
Exactly. So when we look at agents inside an enterprise environment, we might want to consider them as non-human identities, right? So if your agents are performing different types of tasks, maybe again scoping them the same way you would either a system or the same way you would scope a person or a human employee, right? By understanding exactly the type of jobs that they're performing, right, you can understand the tasks that they're performing. By understanding the task, you know how to scope the permissions. By scoping the permissions, you have to assign them a role. When you scope that role, you can now see them in your environment and understand exactly the scope of access they should have, right? When we look at agents, it's more about an access control type thing, where role-based access control is really how we can consider it right now. Eventually, I think we'll need a new way to kind of consider how agents are performing tasks, what intent looks like, and how do we maybe detect intent earlier so we understand when an agent starts to drift. Again, there's also this whole concept of gravitational risk, where an agent can do a thing in maybe one task that impacts agents 3, 4, 5 spaces away, right? Yeah. Yeah. I wish. That would be so fun. No access to Mythos. It was a handful of companies that have access to it, but it's very cool. Yeah.
Is there a measure of the horizon? You said maybe you have more systemic problem. If you see that pattern continue, at what point do you call it hey, this is beyond just guardrailing an agent, and we really need to think about letting it.
Yeah. So I think the question that you're asking is how do you know like when it's a problem with your guardrail versus how do you know it's a problem with like your product? Yeah. So when you're first like mapping out a system or any type of solution or product, right? You want to have a baseline and establish that. So like what does it look like under normal working conditions? When you typically test software, you break it up into different places too, right? So I wouldn't just go say, add an agent and see how it performs. I would say, okay, well, let's see how it goes without the agent. If we're gonna add an agent and this is like an agentic native solution, let's go and see what an agent would typically do and let's benchmark that over a period of time or maybe over a certain number of requests, responses, right? See what it looks like, have an idea of what normal looks like for you. And then you want to throw in like some adversarial testing where like, this is what normal definitely wouldn't look like. How do we make those responses happen too, right? And when you can see exactly how you get outside of normal, you can go and start mapping against that as well. So if you're having a problem that's outside of your agents, this is going to look totally different. But if you have a guardrail or any observability around alignment, this was where you would detect that. If it's a problem with your actual product, then I would say more look at the responses that like and the interactions that users are having or exactly how the agent is interacting with tools or anything like that. Yeah. Yes.
I don't know if this is directly related to drift or not, but I was just thinking about a lot of products that are out there that you purchase that use AI. They tend to focus on using a particular model, even if they say they're model agnostic. But there are also these capabilities. If you build something internally or you're purchasing a product where it will have a fallback AI product. And so everyone does a testing on the AI products that is the baseline without actually looking at the fallback. And I'm curious, have you experienced this? And do you have any thoughts on how that might impact your testing?
Yeah, so actually when I first started at Alice, we found an issue with one of the model providers. We disclosed it, with Perplexity. So they were first releasing their Comet browser, and one of the issues that we'd found was that if you were using the free tier, at a certain point, they would say you can't use our proprietary model anymore, and you'd hit a fallback model. I don't know how old you are, you look pretty young, but like I know back in my day, we had this thing called like a freak attack, where you can go and like force TLS to like downgrade itself and basically, unencrypt traffic, right? But you can at some point you can do the same thing with models, where it's like, we don't want to pay for the more expensive model. You're using like the best stuff, it's so expensive. We're gonna like swap you to something cheap and you're not gonna know about it. And the problem with that when it happens, the model in the background, it doesn't always keep all of the context the same. And in other cases, it'll actually respond differently too, in terms of like identifying itself, so fingerprinting. And this is kind of like how attackers, when they look at models and they use multiple different types of like responses and attacks to identify what's happening, benchmarking a model, understanding what like the patterns look like for different types of models, and then being able to see, well, am I getting degraded responses because they're throttling me? Or is this because the new model is not as good? And if it is a model that I know has like a jailbreak or it is broken inherently, then this is where you could probably go and exploit it. I don't know if that answers your question. I wasn't sure if it was like how do you deal with like a downgrade, or like how do you like safely downgrade your model, but.
It was more about, is that a threat vector? And it sounds like it is.
Yes, it is. Yeah. Sorry for so many words. Yeah.
You mentioned the importance of sourcing use cases or questions from a variety of different teams, design, ops, etc. Have you found any way to sustainably do that, or methods that work to best kind of extract those various functional mindsets?
Yeah, so the best way that I've seen it organized, and I'm kind of biased because I had done this myself, we actually formed an AI like committee at our organization. And what we did was we had the main stakeholders from like product and safety and security. They all got together and we basically gave them about 2 weeks and said, any question that you have to ask about an AI use case, we would like you to send them to us today, right? We would go, we would take it, and we would meet every time like a couple of big high-risk use cases came up. So having a process that can do that, it takes time to set up, but it's extremely sustainable. Because once you have the framework and structure, you can now take a risk-based approach to when you're actually calling all of these people together and when they actually need to be kind of used in order to source use cases. Yeah. Anything else? Okay. Well, if there are questions that you have that you didn't get to ask, please stop by our booth, 330. Yeah, I think that's it. I forgot to put my info, but I'm sure you can find me somewhere. If you go on the podcast page, my face is there, and I think maybe my LinkedIn. I don't know. Cool. Thank you so much.